Let's do an example using the quotient rule. And I'm going to use the second version of the quotient rule that is on your screen. I'm going to use low d high minus high d low over low squared. If you want to use the first version, you are welcome to do that. I just think it's easier to remember the second version. Okay, we have the following example. The manager of a company that produces graphing calculators determines that when X thousand calculators are produced, they will all be sold when the price is P of X equals 1,000 over 0.3x squared plus $8 per calculator. At what rate is P of X changing with respect to the level of production X when 3,000 calculators are produced? So first, let's look what's being asked. It is asking what is the rate P of X is changing. When we see the word rate, that's another way of thinking, what is the slope at that point? To find the slope, we need the derivative. So I need to find the derivative of P of X. Oh, I have my high function and my low function. So let's find the derivative. Let's go ahead and list everything out. So the high function is 1,000. The derivative of the high function, the derivative of 1,000 is going to be 0. The low function is 0.3x squared plus 8. And the derivative of the low function is going to be, well, the 2 comes out in front, multiplies by 0.3, so I get 0.6x. Then I subtract 1 from the exponent, leaving just 1. And the derivative of 8 is 0. So I have all the components. The derivative is going to be low, so 0.3x squared plus 8 times d high, which is 0, low d high, minus high, which is 1,000, times d low, or the derivative of the low function, all over low squared, which is 0.3x squared plus 8. This first term is going to drop out since we're multiplying by 0. So I'm left with negative 1,000 times 0.6. That gets me negative 600x. Oh, I forgot to put the squared up here. The denominator should be low squared. Okay, now the denominator is going to stay as 0.3x squared plus 8 squared. I often get asked if we should FOIL out the bottom, and I usually just leave it. Most of the time that'll work just fine. Now that we have the derivative, the question is asking at what rate, well, we have the rate, that's the derivative, is P of X changing with respect to the level of production when 3,000 calculators are produced. At first, I was thinking, hey, I'm going to put in P prime of 3,000. But going back to the first sentence, X is already in thousands, so I'm going to do P prime of just 3. Now this just becomes a little bit of an arithmetic problem, and we get negative 15.72 dollars per 1,000 calculators. The question also says to interpret your answer. So let's go ahead and write a little sentence. When 3,000 calculators are produced, the price is, you could say changing or decreasing. I'll say decreasing by $15.72. If you use the word changing, I'd make sure you keep the negative there. Per 1,000 calculators. And that's an application problem using the quotient rule.